Hey guys, welcome back to Rocket Gyan, my fellow space tubers. How are you all? How are you guys? I'm so happy I am back with another live stream. We have been, off the radar for quite a lot some time now. I mean, it was not as long as I expected, but again, it was some time. It is long for me. I don't know about you, but I want to meet you guys all day, every month, every year. Okay, so hi everyone. Hi, Babita. Hi, Mark. Hi, All Stats. Hi, Rob. Hi, Philip. And everything is looking good for today. Okay, so we'll get through the rundown of everything you need to know. And as you know, this is like the ritual which we perform before every flight, right? So don't worry about it. And hi, gaming nerd. Hi, Ryan. I hope you all are good because I am very, excited for this one because of its duty at, you know, during the launch and it's a beast. It's a beast. We should admit that. Okay, what is the difference between the Vega rocket and the Ariane 5? I will, go through that. Yehuda, if I pronounced your name right. And we should be getting onto it. So I think without any further ado, we should get into it. Oh, well, past week was bit of a drama for all space fans because of what happened with the last stream last launch which I streamed of the Nioka module, as whatever you want to say. If we get time we will talk about that also, but right now let's focus this one here and let's hope everything goes as per the plan. So Arianespace is the like ULA for ESA or for France. I mean the European Union here. So it's like that company here. And today we have the Ariane 5 rocket launch. So let's get to the rocket itself right now. And yeah, there you go. So the Ariane 5, the heavy launcher, because it can put 20 tons to low Earth orbit, and 20 tons kind of, it's like 5 tons shy of what I will call a heavy launcher, like Long March 5 and Falcon Heavy and Delta 4, but it's okay. It's okay. Yeah, so can be considered. And it's a heavy launcher, as you can see here, and it's one of those rockets which has the hydrogen and liquid oxygen as its core stage. I know it's very ineffective to use that, but again, it's what we have, what engine do we have, what engine can we make, that's how you make decide their propellant also. So they are like expert of the liquid hydrogen liquid oxygen engine. So yes, they went with this configuration. So talking about the Ariane 5 rocket, this has these two solid rocket boosters attached, which looks awesome. Then there is one core main stage, you can say, and this runs on liquid hydrogen liquid oxygen. Then we have the upper stage, and then finally the payloads. Okay, So talking about this engine, the Vulcan 2 engine, its look, you can see there, it is looking, yeah, I mean, it does look awesome to me. I don't know about you guys, but it looks cool for me. And this Vulcan 2 engine produces 1390 kilonewtons of thrust in vacuum. Its nozzle is gimbaled for pitch and yaw control. And talking about this engine, I'll talk about this engine in a detail right now, but you can see how it looks like when it is attached to the main stage, main rocket, I must say that, right? So here you can see it's a Vulcan 2 engine. There previously they used Vulcan 1. Now they are on to the Vulcan 2 engine, which you can see here. Okay, so let's have a closer look on this rocket engine. So this is how it looks like, and this is runs on gas generator power cycle, which we can see from this what do you say, the exhaust coming out of here from the turbines. And here the exhaust, you can say, like, it is not totally discarded. There is some ring kind of a structure going on around this engine, um, which is essential for this. This was not the case with Vulcan 1 engine. This is a Vulcan 2 engine which has this you know uh, ring kind of a structure, which is basically used to direct those cooler gases coming out of the pre-burner exhaust. This is a pre-burner exhaust, right? The gas generator cycle, as we all know, this is a pre-burner exhaust, and pre-burner exhaust is much cooler than what we have in the combustion chamber, and basically the exhaust coming out of the engine. So since it is a cooler exhaust, so some part of that exhaust is pumped back into this ring structure, and this ring structure basically takes that exhaust into this nozzle, and some part of this nozzle, the later part here, is cooled by this exhaust coming out of the pre-burner. So this is the difference between Vulcan 1 and Vulcan 2, major difference. And it's a regeneratively cooled nozzle, which we can say here. It produces around just 8% of the total thrust at liftoff. Almost 92% of the thrust is produced by those two solid rocket boosters. And again, this is an liquid hydrogen liquid oxygen engine. So basically it burns for a lot longer than the other counterparts. So it has a total engine operating time of 600 seconds. So yes, that is the thing here. Okay, coming back to the rocket now. This is the Vulcan 2 engine which we just saw. Then this is the cryogenic stage. This is how it looks like from the inside. And this carries a propellant load of 132 metric tons of liquid oxygen, 25 metric tons of liquid hydrogen. And if you see that the liquid hydrogen requirement is way lesser than the liquid oxygen requirement. It all comes down to that chemical equation balance which we used to do in our high school chemistry books. Because when we burn hydrogen and oxygen, how do we balance it? 4 hydrogen plus oxygen is equal to 2 H2O. So you need 4 times as hydrogen as you need oxygen, just to balance that molar equation which we have get to when we burn this two propellants. So here you can see that. And yeah, the Vulcans, other thing is, so we know anything else. So yeah, this is all about the cryogenic stage, this main stage. And talking about this solid rocket booster, it produces around 90% of the total thrust, which I already told you. Flight and it burns for 130 seconds, and it uses a propellant mixture of aluminium polybutadiene and the ammonium perchlorate, which means it kind of uses mixture of everything to make this propulsion happen. Industrial standard is HTPB, which we all know, which they also use, but they also combine it with other chemicals to maybe increase the efficiency or the thrust. Don't know about the chemistry of the solid rocket boosters right now. So yes, that is the thing. Then talking about the cryogenic upper stage, this is the second stage which it has. And this has this HM7B engines. They're reliable, very reliable engine. 67 kilonewtons of maximum thrust it produces. It also runs on gas generator cycle and uses liquid hydrogen, liquid oxygen as its fuel. So during the powered flight, the attitude control for pitch and yaw can be, completed using the engine gimbal, while the gaseous hydrogen thrusters are used for the roll control, and the ballistic phase, roll, pitch, and yaw uses the gaseous hydrogen thrusters. Okay, the ballistic phase is what? Ballistic phase is nothing but a coast phase. So during the coast phase, obviously the engine gimbal cannot help to help in any type of attitude control. Attitude control. Okay. um, attitude control is the scary word from the past since the last day, because of what happened at the ISS. Nevertheless, if we have time, we'll get to it. But again, so yeah, during the ballistic phase, when it's coasting, it does not uses the engine, right? So so the all the attitude control thing is done by the um, gaseous hydrogen thrusters. And talking about this engine, let's have a look at this engine also. So this engine looks like this, and it has this gas generator cycle is evident from this exhaust pipe, and this exhaust pipe is a bit weird here, which you can see, right? And this is a pretty standard one, but one thing to note for this upper stage, that first of all, this is a regeneratively cooled upper stage, liquid hydrogen, liquid oxygen as its fuel, and this has no restart capability. So this is one thing which we need to make sure, we need to know, because uh, we know that for all those geostationary mission, because today the mission in the satellites are going to a geostationary orbit, basically the geostationary transfer orbit. So for achieving such a higher apogee and doing all those maneuvers, all those other companies tend to relight the engine for the second time, but here that won't be happening. So in just one burn, we will be seeing the satellites placed in the intended orbit, because obviously it does not have any restart capability. So yes, that is the case. And how much time do I have left? Around 8 minutes until the webcast starts. Okay, I'll take some questions right now. I guess if we have any. I don't think so. Um, yes, after a long time we are here. Hi, Nishant. Um, okay, we'll take the questions, but let me just finish whatever I have to, right? Just type down the questions if you have any, and I'll take those. But yes, let's, what else do we have? Then this thing, okay, this fairing, okay, let's talk about the payload. So there are two satellites going to the the geostationary orbit, and exactly this is how it will look like. One satellite will be here in this kind of a payload adapter. This is like a fairing inside a fairing. There is a big fairing, and there is one another fairing which is protecting the first satellite. This type of configuration allows Ariane 5 or Arianespace to deploy two satellites at the same time. And this fairing inside a fairing is nothing but, this is what they call the payload adapter, and they have named it as SILDA payload adapter. Okay, this is how it looks like. First satellite is placed inside this. First of all, the first satellite is placed on the payload adapter, and then the SILDA adapter is placed onto it, and then finally the other satellite is placed. So this is how it looks like. Okay, and I do have one image going on right there. Okay, yeah, this is one. This is how it looks like. This is the SILDA adapter, this is the another satellite, and this is the fairing coming down to enclose all of those things. And inside the SILDA adapter, there is one another satellite. So this is how it works. Okay. Okay, now let's have a look at the satellites itself, right? Okay, just a sec. Where is it? So first of all, this is a EutelSat quantum satellite, as they say. Uh, is not exactly a quantum satellite, which if you are thinking is it a QKD satellite? No, it is not. QKD is like a breakthrough in cybersecurity. Okay. Okay. One video is also coming up if I'll get time. If I'll, if once I'm finished with my exam, I am working on one video which will come up soon regarding this QKD technology, which I'll discuss about in detail. But right now, look at this quantum satellite which it is sending. As they say, this satellite has an orbit reprogrammable feature, making it incredibly flexible as it can repeatedly adjust and respond to changing demands while in the orbit. Okay, it will be capable of adapting to new commands in the coverage frequency, the power usage, and will be even be able to change its orbital position. So it's like the world's first software based satellite which is which can work on demand as per the requirements of the customer. This is like the world's it's not a rigid satellite which is like sent into space and it has to operate as the way it is intended to. Basically they can reprogram the satellite to work in another way. Sometime work in for communication, sometime work for data transmission. So this is like that. Okay. Basically this satellite has a lifespan of 15 years and kind of will work for the data mostly for data transmission and secure communication. So yes, that is one thing. So it's kind of a cool satellite, I must say that. A reprogrammable one which can work like other satellites. So it's kind of a cool one. Okay, moving on to the next one. Okay, this here looks familiar if you have seen it. This is the Star 1 D2 satellite, a communication satellite, and this is the seventh satellite in the Star 1 satellite fleet. And this will provide the high-speed broadband television broadcast and the telecommunication services to South America, Mexico, and the Central America and areas of Atlantic Ocean. It's based on geocommunication and remote sensing platforms. So, it's like a Starlink satellite, but in geostationary orbit. So it covers a much larger area and it's a more powerful satellite than a Starlink satellite. Obviously, because one satellite will be able to handle a lot of loads, and obviously it's a bigger one. Okay, so yeah, that is the another one which is going up in space. Whoever lives and is watching from the South America, Mexico, Central America, shout out to you all, and you should be able to get some proper internet connections after this one is launched in orbit. Okay, now let's have a look at the flight sequence. I guess that is, yeah, the flight sequence, which is the flight timeline, as they say, right? So liftoff will happen at t plus 0 second, t minus 0 second, t equal to 0 second. Okay, t equal to 0 second, then the solid boosters will separate. The cryogenic stage will work, and then the fairing will jettison. See, this is the difference between the others launchers and this, that the fairing jettison happens with the core stage attached, right? And for most of the launchers that is not the case. The fairing jettison happens after the second stage ignites, because that's how they work. But here the core stage is still attached, because the core stage is of liquid hydrogen, liquid oxygen, which burns for a lot longer, and hence it is not preferred for the core stage, which is the booster stage, because then the dead mass or the dry weight for your rocket increases rapidly, because it has to carry on for such a long journey. But it is a preferred fuel, the most preferred fuel for the upper stage, again for this property only, that it can burn for a lot longer for a relatively small amount of fuel. So that is the thing here. And then the main stage will separate, then the upper stage will separate, obviously. Then the upper stage will ignite. Here you can see that then the after the upper stage ignition, putting it into a desired orbit. And talking about the orbit, it is around 250 kilometers by 36,000 kilometers. So that is the orbital range here. Then after that, when the cryogenic stage has injected both of the satellites into the orbit. First of all, the Star 1 D2 satellite will separate, which is placed on the top, and then the Silda will separate, which is the adapter, and then the EutelSat communication satellite will separate. Okay. So yes, that's how it looks like. I think that's it. Yes. Let's see if we do have. Okay, we do have the stream, so I'll switch over to that. And if you have any questions, you can surely ask me. But right now, launch time. Yes, it's coming in. I am switching over to the live stream, so let's watch that. And I hope I have covered everything that you need to.
Ariane's main base of operations over there and be giving you privileged access inside the Jupiter control room for some exclusive behind-the-scene coverage.
And here in the Paris studio with Emma, experts will do our best to reply to all the questions we received via social networks. But before that, let's take a look at tonight's menu.
Tonight, in Road to Space, we'll be live from Guiana Space Center with all the team. We are here, of course, to witness the launch of the Ariane 5 rocket, which will be sending 2 telecommunication satellites into orbit.
Star 1 D2, in 3 words, multi-mission, high performance, and connectivity.
Here, in the Paris studio, we'll be talking to Space's top experts about the launch and showing you video reports on what the future holds for satellites.
Quantum is at heart the start of a revolution.
You will learn how a telecommunication satellite works, and we'll be giving you an exclusive look into the latest advances of the new European rocket, Ariane 6.
Je vous propose de le découvrir de l'intérieur.
We'll also be answering all your questions on social networks and looking at the film Stowaway to find out if an intruder really could sneak his way aboard a rocket.
Wow, this looks like a cool coverage today.
That with Road to Space, you will spend a truly magical and unique night in our company, where Earth meets space and the present embraces the future. Welcome aboard Road to Space.
Wow. I am so excited for this coverage now.
Really happy to be with you tonight, and let's go directly to Kourou to meet our special first guest, Arianespace CEO Stéphane Israël. You're waiting for us. Hello, Stéphane. Welcome to Road to Space. Just one question. I see you're all on the deck, getting ready for this upcoming flight, and it's a very special one. It's the Ariane 5, the European heavy launcher.
Yes, it is a very special launch tonight. It is the first launch of the year with Ariane 5, and we have on board 2 long-lasting partners of Arianespace. We have with Star 1 D2 the operator Embratel. We have launched all the satellites of Embratel, and the other partner is our long-lasting friend EutelSat. We have started our relationship in 1983. So with Star 1 D2 and with Quantum, we have really long-lasting partners tonight on board on Ariane 5.
Yeah, 2 special guests, 2 special passengers for you. And in a way, this launching is the climax of this campaign.
For sure. So we are now a few minutes before the launch. And, you know, for having the liftoff at 6 o'clock p.m. Guiana time tonight, we need the satellite to be ready. We need the launcher to be ready. We need also the weather to be with us. We have now the final minutes up to the launch. We have a lot of very important operations to do before lifting off. So let's see how things are going to turn out. And we are confident for the liftoff.
We wish you good luck. We're sure everything is going to be perfect. Thank you very much, Stéphane. We'll come back to you a little bit later. And for all of you watching live, we will, of course, come back to Kourou regularly to inform you.
But for now, let's welcome Amandine Lux, who's just joined us into the studio. Good evening.
Good evening, Amandine.
Good evening, Emma. Good evening, Baptiste.
Welcome to Road to Space. You are Arianespace's Advanced Studies Director, and tonight you will be connected with Kourou, thanks to a little earpiece, and giving us regular updates throughout the program about the mission. But can you explain to us, firstly, what are the principal stages of the mission?
Yes, so we can have a look. We have a little animation, so we can have an overview of what we are going to witness tonight. So at H0, an important event, we will have the main stage engine ignition. And so after a few healthy checks, it will be followed by the ignition of the boosters. So I'm waiting.
Should be getting some images up on the
I'm
screen
waiting for
soon.
the animation.
Okay.
We should see this animation. Well, normally it should appear on the.
Here it is.
Yeah, so that's it. So
we get it.
you will have the liftoff with the boosters ignition, and after a quick ascent phase, the launch vehicle will perform the pitch maneuver in order to get to the right direction. A few seconds later, after, when they are no longer needed, the boosters are separated from the launch vehicle. And after that, we will separate the fairing, which protect the satellites, when it's no longer needed once the launch vehicle reaches out the atmosphere. So the main stage propel phase goes on till we reach the intermediate orbit. At this stage, we cut off the main stage engine. You have a distancing maneuver, and there will be the ignition of the upper stage engine after the separation of the main stage. So this second propel phase goes on till we reach the final orbit, the injection orbit, and tonight for our customers it will be the GTO orbit, the geo transfer orbit. The same as for the main stage, the engine we cut off when we reach the final orbit, and we enter then the ballistic phase, to which we will separate our customers. So first Star 1 D2, and after a few maneuvers of distancing, we will separate the dual launch structure because we have a second passenger. And so after the SILDA separation, this dual launch structure, we will separate our second passenger, EutelSat Quantum.
Okay, so those are all the points we have to follow, especially with you. And so you will be the one commenting with us all those key points happening during the launching. Well, thank you very much, Amandine. You stay with us. We'll come back to you shortly after. But before we are going to take a look at Star 1 D2, one of those two satellites that will be launched tonight. Star 1 D2 will improve access to high-quality entertainment and information services in Central and South America, and it will also connect underserved.
Guys, you can see the big screen is right now green, so that means that everything is looking good for the launch, the weather, the engine, everything basically. Yeah. And if you have any other questions, you can just write down in the chat and we'll have a look at it. So
Star 1 D2 is the largest satellite ever launched for Embratel. It is the latest in a fleet of 12 satellites. Its role? To boost the coverage of satellites already placed into orbit for the operator. Kourou is a leading telecommunications company, and Embratel is part of it.
Satellites will continue to be an important part of our infrastructure and business. We are part of the American Mobile Group, a leader in the telecommunications market in Latin America.
Star 1 D2 was built by Maxar at the manufacturing facility in Palo Alto in the United States. The satellite will be launched into geostationary orbit 36,000 kilometers above our heads.
Star 1 D2 is an important project for Maxar because of our partnership with Embratel in the geostationary communications market. We have been working on this satellite here at Maxar since the fall of 2017.
For over the past 36 years, Embratel and Arianespace have developed a strong and fruitful partnership. Since its creation in 1985, the Brazilian operator has entrusted the launch of all its satellites to Arianespace. And Star 1 D2 does not escape the rule. The CEO of Embratel explains to our journalists why the company always chooses an Ariane launcher.
We are working with the key international players to have the best combination of technology, cost, and performance.
Star 1 D2 will improve access to high-quality telecommunications and television services. It's intended to meet the needs of individual users, but also for businesses in South and Central America. The new satellite coverage will reach millions of people.
The most important technological challenges that we had to overcome to build this satellite were the fact that there were many diverse payload bands to make this satellite operational.
This hybrid satellite is composed of 4 different bands. The X band is for military use only. Star 1 C band has exceptional power. Thanks to this, the satellite will be able to offer television coverage to more than 20 million satellite dishes in Brazil. The KU band will accompany the country's transition to 5G, a government requirement. With the KA band, Star 1D2 will significantly increase its mobile coverage capacity, particularly in the north of Brazil, which is one of the regions most affected by terrestrial connection problems. All of this will of course greatly benefit the population here. Each satellite beam will be able to connect 4,000 schools to the internet in the most remote areas. The development of the KA band in Brazil will also have an important impact on the agribusiness market.
To reach remote areas is our aim, to be the best option in all the market. With a great coverage of satellite, we will help transform businesses by bringing more possibilities for companies to reinvent themselves and to improve their service, in addition to providing people with more ways to communicate and be entertained.
Star 1D2, like the rest of the Star 1 fleet, will be controlled and monitored from the largest satellite control center in Brazil and Latin America, the Guaratiba Center. Created in 1983, it is located in the west side of Rio de Janeiro. But before taking off into space, the satellite had to go through another somewhat delicate journey. Its transport from Palo Alto to Kourou, in one of the largest cargo aircrafts in the world. Star 1D2 is now ready for its ride into space. Before this satellite takes off and finds its place amongst the stars, let's welcome our space expert, Raphaël Chevrier.
Welcome, Raphaël.
Welcome.
Hello.
You are a business developer in charge of innovation at Arianespace, and the question I want to ask you tonight is, today we can talk to whoever we want, anywhere in the world, but what about tomorrow? What does tomorrow hold?
Well, first of all, I'd like to remind that half of the population worldwide still lack of a reliable internet connection.
And
so
talking about how this will, compete with Starlink. Starlink is, operating with the personal service. Like, you can literally buy it. But for this, I don't think so that is the case. Maybe it is, having connections to the organizations, but let's see.
A Japanese satellite, BSat-4B, who is right now providing TV broadcast in high definition for the Olympic Games that are happening right now. And I just wanted to remind that yesterday we had an engineer at Ariane Group, Astrid Guyard, who won the silver medal in fencing, and I want to congratulate her.
Wow.
Yeah, congratulations. What I understand is that it can change things for me as an individual, but what will it change for companies?
We can think of like very unlimited application there. If you have like a strong connectivity, you can apply it to moving targets like trains, boats, autonomous cars, planes, and etc. There are strong implications in telemedicine also, with tomorrow doctors being able to really take care of a person's health remotely in real time, and to assist, for example, a chirurgical act at distance. And also all applications related to Internet of Things, so that tomorrow you can actually monitor your house at distance remotely in real time, anywhere.
Well, thank you for all those information. You stay with us because we are going to focus now on the second satellite that will be into orbit tonight.
Yes, Baptiste, and this satellite is EutelSat Quantum. It was developed by ESA with the operator EutelSat and the satellite manufacturer Airbus. It is what you call a game-changing piece of technology. To understand how innovative it is, let's watch this short report.
They do have improved
It
the
took place
coverage.
a few days ago on Toulouse's Airbus Defence and Space facilities in France. It is here that the manufacturing teams were preparing to ship the satellite, EutelSat Quantum, before its long voyage to French Guiana, a rigorous operation in a sterilized room under controlled atmosphere. This 3.5-ton jewel of technology is the new benchmark in telecommunication satellites.
The EutelSat Quantum will be the first world commercial telecommunication satellite fully reconfigurable in orbit. Standard geostationary satellites are configured during construction over fixed coverage. With this new generation of satellite, you will be able to modify the coverage and to pinpoint a specific area and to define a route to follow a plane or a shipping vessel.
EutelSat Quantum is paving the way for a future generation of satellites and is a great example of international cooperation.
As you can see, the final assembly is done here in our facilities in EutelSat Space in Toulouse. You can see the satellite behind me. And it's made of many components coming from Europe. The platform is coming from our subsidiaries, SSTL, for which we have developed this product for the low range of our satellites. The fully flexible, innovative payload has been designed and built in EutelSat Space in Portsmouth, where this payload has been totally innovated. So the development of EutelSat Quantum Active Antenna is a new technology that is developed in Spain and that is paving the way, positioning Airbus as a leader for flexible payload.
What makes EutelSat Quantum so groundbreaking is its new multi-beam antenna. As we can see in this visual animation, its technological feat lies in its mobile aspect.
One of the main challenges and a great achievement for Airbus is the groundbreaking multi-beam active receive antenna named EutelSat+.
Oh, what the hell happened? Check. Not from my side. No, not at all. This is what has happened to their broadcast. I can switch over to the another one, but
first commercial software-driven satellite with the ability to change both the frequency, the power, and the direction and shape of the beams that are being broadcast down to Earth.
Dans quelques minutes, EutelSat Quantum décollera à bord d'Ariane 5. Destination finale, 36 000 km en orbite géostationnaire. De là, le satellite offrira une couverture étendue.
The satellite will be located at 48 degrees east and will cover a large region over the world from Europe to Middle East.
Mais surtout, il sera capable de s'adapter à tout moment et en une dizaine de minutes aux besoins du marché.
Traditionally, our customers are able to reconfigure by software control in order to adapt to changing market conditions.
Quantum is leading in the field for software-driven payloads on commercial spacecraft because it is the first to respond to a market demand for ultimate flexibility for customers.
With this new standard and flexibility, EutelSat Quantum will provide communications on the move as required by aeronautical, maritime and land transportation. It will also provide a rapid response to civil protection, natural disaster response and security missions, all using the latest encryption technologies.
In a few minutes, we'll be linking up to Kourou for the launch of the Ariane 5 rocket. But for the moment, Raphaël Chevrier, our space expert, is with us. Raphaël, let's talk a little bit more about EutelSat Quantum. And in the report we just watched, we talk about a geostationary position. What it is?
Yeah. Well, this is the position where the satellite is actually going. It's at 36,000 kilometers from the Earth. It is a very convenient orbit for telecommunication satellites because the movement of the satellites there are synchronized with the rotation of the Earth. It means that they can actually provide the same applications all day long to the same region because they are facing the same region. So
they're turning with the Earth at the same time.
Exactly.
Okay.
So yeah. So 24 hours a day they can deliver services there.
Okay, and also we've heard about the fact that the satellite will be placed at 48 degrees east. Yeah. Same question, why?
Well, because this location corresponds to the region that the satellite wants to actually deserve the application. So in this case, it corresponds to a broad region from Europe to the Middle East. And well, you've heard in the report that EutelSat Quantum is actually like a real concentrate of technology because this is a reconfigurable satellite. It means that it is as flexible as operating several satellites in orbit at a time, and it can quickly adapt to the market change geographically and in terms of frequency bands.
Okay.
So it's a real game changer.
Yeah, it is opening a new way of doing business in space. Yeah.
Oh, thank you very much, Raphael. And for all you watching us live, just stay with us because we'll be heading back to Kourou in a couple of minutes. But just before, let's watch what's coming next.
Tonight on Road to Space, we are live from Guiana.
So, okay, again, this happened. So there is some connection problem, but they will, recover it from that. So, yes, I do stream every other launch that happens in space industry, and not only the launches, but the events also, the space events, like anything which happens in space, basically. I do everything. What has happened to this one? I just really don't want this to happen again during the launch. Okay, I'll have to switch over to this for some time. And thank you so much, Greg, for that $4.99. And that really helps me. It really helps this channel to stay alive. And your small donations keep me motivated. So thank you so much, and keep watching. And you can even become a member if you want. So and that will help me too much. Okay, so you can become a member. The join button is there, and you can get the exclusive perks. So let me see if we do have the English version running. Okay, cool.
100 kilometers or less or more?
Well, this question probably refers to the recent debate there was between two entrepreneurs that went to space. Richard Branson, who went to 80 kilometers of altitude, which is recognized as the space limit by NASA, and Jeff Bezos, who went to 100 kilometers of altitude, which is recognized as space limit by the International Aeronautical Federation. The reason for this debate is that the atmosphere is a continuous medium with no real limit. You can travel hundreds of kilometers and you will still find particles like in space. So as a matter of fact, the atmosphere ends at 950 kilometers from the Earth. We don't really have this debate at Arianespace because we are launching satellites well above 100 kilometers of altitude, several hundred kilometers of altitude. And so we launch the satellites there, and it requires a huge amount of energy, right?
Yes, and talking about the atmosphere.
When you're designing rockets, this is really a huge matter because, as you said, you're going through a continuous medium. You know exactly how you need to model it very precisely when you do simulations, because even though at 80 or 100 kilometers you don't have that many particles, still you are going through this medium at a very, very high speed. We're talking about 2 kilometers per second, and you know how many kilometers per hour it is, right?
Yeah.
Yeah, 7 to 8 thousand kilometers. Yeah, you did the conversion, of course. So from there, all the particles you will heat will create some aeroflux, and you need to be very aware of that in particular to determine the exact instant when you're going to separate the fairing, because you don't want the satellites that are protected by it to be hurt by these particles.
Okay.
So we have an end of question. Would this be of any operational importance for engineering, science, or legal reasons?
So for engineering, obviously, but even for the International Space Station, this is an issue because at 400 kilometers of altitude, they're not that far. There are still particles, and they're actually decaying slowly because they're hit by these particles. So they need to be reboosted from time to time.
Regarding science, this is why in the
attention pour la séquence finale lanceur.
Well, sorry to interrupt you guys. Actually, we just heard the DDO.
Top à 0-7 minutes.
So it's 7 minutes away from the launching. Amandine, can you explain us who is this guy and what is this announcement?
Okay, so the DDO is the Range Operations Manager. And so tonight, as I am, he will be connected with the Telemetry Control Center. He will receive all the information so that we can follow what are the main milestones during this flight and that we are on track regarding the launch. So now we enter the synchronized sequence, so that means that we are good to go. We will get the launch vehicle ready for liftoff. We will perform the isolation of the ground vehicle.
Do I comment and maybe dim their voice? What do you want to do?
the panel behind you with all the greens. So that means that the space base is green. So space base ensures the means to track the launch vehicle and also the safety, the security. They monitor the safe weather conditions. We have, of course, the launch vehicle. And
the weather is important?
Weather is
even
really
to launch
important.
a rocket?
It's really important. It's really important at liftoff.
I ask you that because we can fly with planes on every weather.
Yeah,
so.
lightning are monitored
This
because
guy,
you don't
I
want
love
any
this
kind
guy.
of explosion at liftoff. And after that, you know, the trajectory is computed following certain conditions for the forecast. And you don't want to have, for instance, high velocities for the winds because of that. Otherwise, you would have some risk towards population. And so the last green that you need, of course, is the one from our customers. So now, this is the final autonomous sequence. Everything will be transferred to give autonomy to the launch vehicle. It will be isolated from the ground. We will give the power to the launch vehicle. The launch vehicle will be the brain of itself, and it will be ready for the liftoff with the last operation, the preparation of the ignition of the main stage.
Okay, I'm sorry to interrupt you because I have the clock over there. We are 5 minutes away from the liftoff. Let's go to Kourou and let's go to the Jupiter control room to see what is happening over there. Hello, Cyrielle. Good to see you. You are our correspondent for Arianespace tonight, and you are going to be reporting for us from behind the scene in this famous Jupiter control room. Well, my question is simple. What is that room? I guess it's what we see behind you.
Sound suppressed room.
Hello, Baptiste, and welcome. Yes, as you've said, I am in the Jupiter Control Center, and more precisely in what we call the fishbowl. This is the place where we receive all the information regarding the spaceport and the Ariane 5 status. But let me introduce the teams. So just behind me in the front row and a little bit of the second one over there, we have the CNES launch specialists. They are in charge of coordinating and monitoring telemetry, weather data, telecommunication system of the spaceport, and so many other things. Now, right here on the second row, we have the satellite operators and manufacturers. They are here to monitor their spacecraft.
Actually,
Afterwards,
they will confirm the yes, that is the case. This is not from my end. This is from the back end only. That you know, particles in the sound. That's what you should say. So it's like 3 minus 3 minutes until the launch. Everything is looking good. Let me just sum up whatever is happening. Everything is looking good right now. We are T minus 3 minutes until the launch. The weather is fine, and the rocket is fine. And we still haven't got the images from the rocket itself, so that is you know, a big negative. But again, and talking about the reusability, there is another, you know, the rocket coming up, which is the Ariane 6, and you know, Ariane 6 will be kind of, you know, like Vulcan, which means it can, you know, fly in different configurations for different payloads, but that is expendable, so that is not reusable. But Ariane, you know, the Arianespace is kind of working on the reusability also. But first of all, their main focus is on making Ariane 6 possible, and then finally they will do that. So that is one thing. Any news on the OFT2? Yes, Christian Brown Productions. Right now, the Starliner launch was delayed because of the NIOCA issue with the ISS. It literally, you know, messed up with the ISS, but now everything is under control. So every other schedule for the astronauts and everything has been, you know, is messed up because of that, and that's why the delay is there. And right now it is scheduled for 4th August. It was scheduled for today, but because of all those NIOCA things, it is scheduled for 4th August. And we are right now T minus 1 minute and 37 seconds until the liftoff, and everything is looking good here.
We'll let those people concentrate because we are 1 minute and 28 seconds away from the launching. So from the liftoff. So now we're gonna watch the show, because this is what we are here to enjoy the show. And
yeah,
cross fingers.
That's not exactly how we call it as engineers.
Yes.
Okay, so T-minus 1 minute, and let's please get the looks of from the rocket. We are T-minus. Okay, T-minus 1 minute.
So it's one minute away from the launching. We hear the DDO. This is the DDO
There we
speaking,
go,
announcing.
finally. The weather is kind of not looking, you know, very favorable, but I guess Ariane 5 can handle those. They are, you know, like kind of robust rockets, so that is there. August 3rd, or okay, August 3rd in your timeline. So
I guess everybody over there is
so
concentrated.
the thing is looking good. T-minus 30 seconds. Now is the time, guys. Everything is looking great right now. We are T-minus 26 seconds. 24, T-minus 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. Enjoy the show.
6, 5, 4, 3, 2, 1, top.
Ignition, rough ignition. Vulcan coming to full thrust, and we have lift off. Whoa.
Maneuvers ongoing.
So impressive.
Remettre à bord nominaux.
Everything looking nominal right now.
Well, we have just seen Ariane 5 disappear towards space. Do stay with us, everyone, because what's going to happen next is as crucial as the next launch. This is, of course, the moment when the two satellites, Star 1D2 and EutelSat Quantum, separate from the launcher and are placed into orbit. But that's not all, is it, Baptiste?
Yeah, I guess it's not all. I was really watching at those
impressive
images. And to answer your question, I'm going to ask Amandine. So, Amandine, how many kilometers does Ariane 5 travel before the launching of the satellites?
So, in fact, Ariane 5 is not going to go to the GEO orbit, this orbit of interest. That would be quite a journey. So, we are going to the GTO orbit, so the Geo transfer orbit, which is an ellipse around the Earth. Which lowest point is close to the Earth. And so this is where the upper stage is going to get us. We will reach roughly an altitude of 650 kilometers. And this orbit, as an interest, the highest point is located at the same radius of the GEO orbit. And so that will be up to the customers once they are released into the GTO orbit to get to the GEO orbit and to do the final maneuvers to circularize the orbit and be in GEO orbit.
I guess, and I hope everything is calculated and programmed. So what is the role of the team in Kourou right now?
So everything is pre-programmed on board, but you remember I talked about the onboard computers. So the launch vehicles knows exactly where it is located, what is its acceleration and velocity. Yeah. And so it will reach the orbit by recomputing the orbit every time in order to get the maximum performance and the best accuracy. Right now, the main active people in Kourou, you don't see them, they are in the
separation is coming up, guys, the SRB separation. There we go.
Booster separation.
Yeah, the booster separations.
Confirmed. There was a little bit of a roll, and right now the Vulcan is doing its job, and we can see it's being doing kind of a pitch over maneuver. This it does because when it passes from the upper the dense part of the atmosphere, it does not do strong pitching, but when it is pass over that, so it does correct its trajectory for matching the intended trajectory. So that is the thing.
And so the onboard computer is going to trigger the separation of the boosters. And so roughly, usually it happens within a few seconds in comparison to the prediction.
And now we will be witnessing the next step, I guess.
The fairing deploy.
I did have the confirmation, so now it's the separation of the fairing. So the fairing was there to protect the satellite from the acoustic in ground, because the liftoff creates a lot of noise. and from the atmosphere, as it was mentioned by Mathieu and Raphael. And so we separate the fairing, same the onboard computer, we compute everything, knowing exactly what is the velocity, what is the altitude. It can recompute the flux. And when we are under the threshold, the maximum flux that we authorize for the launch vehicle and for our customers, the onboard computer triggers the separation of the fairing.
Okay. I guess now, more or less, Ariane 5 is out of sight. How will we keep the link? How will Kourou keep the link with the rocket?
We will keep the link with the rocket thanks to a network of ground stations, which are in visibility with the launch vehicle. They receive what we call the telemetry of the launch vehicle. Telemetry are the key flight measurements.
I don't understand one thing. I mean, it's okay. They have these people talking over. It is good, but it would have been, you know, great if we have this, if they have this great animation going on. So why not have a great that animation only on the full screen? And so this thing, I don't understand. They can just comment over that video, that animation. But it's okay, I guess.
And after that, the launch vehicle will be tracked by another network of stations. So it will be followed by Natal in Brazil.
I you know, appreciate the information they are giving. That is really cool. But it would have been really cool if we have the onboard cameras also.
So right now we are at an altitude of roughly 160 kilometers, and the speed is above 3 kilometers per second. And
okay.
So
to explain the audience, you have all the numbers, all the data in front of you.
We do have the data. And so what is worth mentioning is that now the mass is only of 160 tons.
And before it was what, 775 tons?
Yeah, so
it's enormous.
Reason for which we separate these boosters, because simple rule in space, the lighter the better if you want to get faster.
Lighter.
Okay, so let me do this thing. Right now, we have the altitude of 166 kilometers, and the trajectory, the intended trajectory, is matching the, you know, the trajectory which it is going. And we are right now 3.9 kilometers per second. Everything is looking good. And talking about one question which appeared in the chat, which was, how do they keep the boosters from colliding with the core stage during the separation? Well, that's a good question, guys. See, this is the thing. The booster actually is firing at a 90-degree angle. I mean, the thrust which it is producing, it is in the upward direction, and the separation force is applied in a 90-degree direction to it. It's in the horizontal, if you consider the upright position as the reference point. So that's in the horizontal direction, and the booster thrust is in a vertical direction. So if you apply force in a 90-degree configuration, so it does not interfere with the you know, the booster's force, whatever, you know, less force, also less thrust it is producing, it will not interfere with that, because the separation force is applied 90-degree to the thrust force. So now coming to the separation thing. So separation, I do need to read about how the the booster separation happen in this rocket, but mostly in, you know, most of the rockets we do have some separation motors going on, or the pyros, which do apply some force and you know, more force on the upper side rather than the, you know, below side, what you say, the bottom side. And if you have played KSP, you know how those things work. So yes, that is the case here.
Yes.
So right now, yes, the thing is looking good. Altitude 100 again. Again, the loss of communication, not from my side, but from their side. Very good. I guess it will be back in a second. This is not cool enough. I mean, they tried to, I had, you know, great expectations when they said everything which they will be covering for today's launch. But I guess that was not the case. And this is not looking good. Not looking good. Again, the French stream is still on. But The English one has those issues with it. Wow. Okay. So see, right now, see, as I told you, the core stage is still firing, and now it has finally, stopped firing. So it is right now at 164, and there we have the separation and the second stage ignition. So that is good. The velocity is still 6.9 kilometers per second. That means it has not reached orbit yet. It has to reach the orbit first of all, and then it has to raise the apoapse also. All of it has to be done in just one burn, which is happening right now. So yes, let me see, we do have the English coverage now. Come on. I guess that is not the case.
Now focus on today's passengers. 2 telecommunication satellites. How do they work?
Okay.
Do they work? Well, the answer is in this short report, guys.
Whoa. What is a Okay, we can listen to this at least. What is a telecommunication?
To understand how a communication satellite works, you'll need to get the bigger picture. A satellite is made up of 2 parts. The service module or bus is the part that contains the equipment necessary for its operation. The other part is the communication module, called the payload. This is where the antennas and electronic equipment are located. Information is sent from a ground station, which then transmits this information to a satellite in the form of high-frequency signals. These signals arrive in the transponder, which receives and transmits the signal. They are then sent back to one or more other ground stations and relayed by antennas or cables to the end user. Looking up at the sky, we could notice that some satellites remain fixed and others move quickly. This is because they are not located in the same orbits. A satellite that remains fixed is in the GEO orbit, for geostationary. At about 36,000 kilometers in height, at the equator level, it revolves with the Earth. This is why it seems to be fixed in the sky, while it is moving at 3 kilometers per second. At this altitude, the satellite constantly covers a very large geographical area that never changes. To serve specific applications, geosatellites will need a hand. Some of them need a latency that is extremely low. Latency is the time needed for the signals to reach the satellite and return back on Earth. Less than 500 milliseconds on the one hand, less than 50 for low Earth orbit, LEO satellites. But as they are lower, between 400 and 2,000 kilometers of altitude, they move faster and cover a limited geographic area for a short time. They are then operated in constellations.
Wow.
Well,
this
Raphael,
was
watching
one
this
good
report,
thing
we
which they
understood
did.
that the future of satellites is, in a way, in constellation. And we've been talking before the show, and I was talking to you about Jeff Bezos and Elon Musk. Elon Musk and Jeff Bezos. I heard they plan to send more than 45,000 satellites. My question is there enough room over there?
Well, just look at the sky and you can see that it's vast enough to host like many planes, for example. And space, it's much better because the more distance from the Earth, the more space and volume you have to be filled with satellites.
Like 4 times.
It's not an issue in geostationary orbit because it's very far from the Earth. In LEO orbits...
L'acquisition de la télémesure par la station de Natal.
In low Earth orbit...
Sorry to interrupt you. Amandine, what does it mean, Natal?
Yeah, Natal, so that means that we have the
Perte de télémesure nominale, attendue.
Yeah, it was as it was planned, so we had the acquisition. Okay, so yes, there will be a gap of visibility, but that's completely planned, that's normal. Okay. And so during this phase, which is a quick one, all the data will be recorded on board. Okay. And so they will be transferred down to the next one station.
Acquisition de la télémesure par la station d'Ascension.
So Ascension will recover whatever has been downloaded, and it will be analyzed by the team.
Well, okay, everything is perfect. I'm sorry, we can go back to that question. Is there enough room over there?
Yeah, I was saying that the low Earth orbit is more like conditions, and I think that the main issue is to really set common rules in order to regulate the traffic, like we do it on the road and on the seas, in the air, of course. And the main challenge is to do it in a sustainable way. And in order to really avoid the satellites to collide with each other, that would generate many debris. And of course, that's not good in order to continue to do activities in space.
Okay, and just one quick question. I feel I have everything I need with my phone. What satellites and constellation can give me more?
This is because you live in Paris, a big city.
For you?
And so, yeah, no, I mean, satellites are like a very good, even in big cities actually, satellites are good solutions to bring resilience to terrestrial networks. But it's also a matter of sovereignty for states, and this is why the European Commission is working on its own constellations of satellites in order to bring internet connectivity to European citizens.
Okay, well, thank you very much, Raphael. In less than 15 minutes, we'll go back to operation.
Okay, so yes, so I love this guy. No matter what you say, he asks valid questions for the normal people to understand. That is one thing.
Eager to hear more about.
And
I'm referring to Ariane 6.
okay,
Ariane's
so
group next generation launcher.
Let's
look
listen
at this
to the
report
Ariane
and we'll
6
talk about it
updates.
afterwards, so sit back and enjoy.
And yes, it is supposed to happen March 2028. That is one thing that is supposed to happen, and I'll explain you why.
From Ariane 5's launch pad, the future is well underway. Here at Ariane 6's launch zone, it's been a hive of activity with its new impressive mobile gantry built on the launch pad and Ariane 6's assembly building. Work was carried out on 170 hectares of land surrounded by a tropical jungle, which now hosts the launch complex Ella 4. Thierry Vallée is the site manager for CNES.
Nous nous trouvons actuellement entre le bâtiment d'assemblage lanceur et la zone de lancement sur la route qui relie donc les deux installations.
A giant mobile gantry has been built. It is 90 meters high and 50 meters wide and weighs in at 8,000 tons. It is heavier than the Eiffel Tower. The inside of this structure will be used to protect the workers in case of bad weather while they assemble the launcher.
Le portique d'Ariane 6 a cette particularité d'être mobile parce qu'il a besoin de pouvoir être déplacé de 140 mètres vers le nord pour dégager le lanceur quelques heures avant le décollage.
The infrastructure is already well underway, and since April, tests have been carried out in the spaceport, as you can see from these impressive images. Around the launch table, 60 valves must open in less than a second to let 30,000 liters of water gush through per second.
Le lanceur donc émet des gaz chauds à plus de 3000 degrés et génère des vibrations à 180 décibels, donc c'est à peu près 1 million de fois le bruit d'un marteau-piqueur. Et donc on imagine bien qu'il faut protéger les installations de toutes ces agressions lors du décollage. Les 900 mètres cubes d'eau qui sont nécessaires au déluge viennent d'un château d'eau qui conserve donc cette eau à plus de 80 mètres de haut.
After the launch, the water is pumped and sent to a water treatment plant.
Tous les paramètres naturels de l'eau vont être vérifiés et contrôlés. Et au bout de 2 semaines environ, donc l'eau pourra de nouveau être relâchée dans le milieu naturel.
In the meantime, the launcher is also getting itself ready. Ariane 6 has just passed its biggest technical challenge to date, the engine tests, which were all successfully completed.
Tous nos systèmes propulsifs ont terminé leurs essais de qualification et on a maintenant devant nous la démonstration que ces systèmes propulsifs fonctionnent dans leur environnement du système lanceur général. Ce sont les essais à feu à Lampolshausen et en Guyane. Les 2 grosses innovations, c'est sur les boosters à poudre avec une enveloppe composite. Et l'APU, ce système cryotechnique multirôle, est unique au monde et on l'a inventé dans le courant du développement.
At the foot of the rocket, the P120C boosters, which also equip the Vega C launcher, can be integrated with either 2 or 4 boosters on Ariane 6. They provide thrust during the first 135 seconds of flight and ensure escape from the Earth's atmosphere. The second engine, the super powerful Vulcain 2.1, is the main stage engine and provides a thrust of 140 metric tons. Then comes the Turner Vinci, the upper stage engine. It's reignitable and enables improved precision on all types of missions and towards all orbits. The fourth motorized system, the auxiliary power unit, is the rocket's major asset. It enables payloads to be deployed into several orbits. This is crucial for satellite constellations.
Pour le lanceur lui-même, on a défini l'architecture du lanceur. On s'apprête à déposer la définition que l'on va qualifier pour aller en vol. Et à côté de ça, on a commencé à produire les étages. Un premier étage supérieur est sur son banc d'essai à Lopolshausen pour réaliser des essais à feu dans les semaines qui viennent. Et on réalise également le lanceur qui va partir en Guyane en septembre pour réaliser les essais combinés du sol et du bord.
In Kourou, the European Space Agency, which funds and manages the entire Ariane 6 program, supervises the work carried out by CNES and Ariane Group.
Ici, nous nous trouvons devant le BAL, le bâtiment d'assemblage lanceur d'Ariane 6.
The agency is the architect of the project and is the main link between Europe and Guyana.
Dans ce bâtiment, nous intégrerons à l'horizontale, contrairement à ce qu'on faisait sur Ariane 5, les deux étages, corps central d'Ariane 6.
For the moment, this is just a mock-up at the launch pad. Once the technical qualifications of the rocket elements are completed, Europe's spaceport will start its combined tests.
Pour ces essais combinés, nous aurons les premiers éléments maquettes, mais des vrais éléments lanceurs qui viendront des Mureaux, de Bram, etc. ici en Guyane, s'interfacer avec les éléments du sol développés par le CNES. L'objectif, à la fin de ces essais combinés, c'est l'autorisation de la première campagne de lancement Ariane 6.
In Ariane 6 schedule, this is the last step before its inaugural flight.
That is not being told. Okay.
Welcome to the living room, Road to Space's living room.
Nominal,
Raphaël and
propulsion nominal.
Mathieu Chaise, you have been working for the Ariane Group, and you are more specifically working for Ariane 6's development program since day one. Ariane 6's maiden launch is programmed for next year. Can you tell us a bit about what technical changes have been made to this Ariane as opposed to Ariane 5?
Well, I'm very happy about this report because you could really get an overview of everything that's new, and you could see the facilities we have and the new means, and with this means we'll be able to operate, manufacture, assemble the launcher in a cheaper and a very efficient way. This is a really big change. Also, the fact that you could play with a number of boosters, either with 2 or 4 boosters, means that with Ariane 6 you actually have 2 launchers for the price of 1. And finally, the big game changer to me is the upper stage. The upper stage, cryotechnic upper stage with Vinci and APU engines that we can reignite in orbit. And from there, it opens many perspectives in terms of missions.
Yeah, I agree with you. We can do like many type of missions to any orbit. It's also important because you can actually do rideshare mission. You can accommodate as many satellites as you can under the fairing and to separate them in different locations in space. And of course, this is very important to deploy these constellations of satellites.
And to the moon?
Okay.
Yeah, as a matter of fact, we are preparing the first European mission to the moon with Ariane 6. It's going to happen during this decade. And we are also preparing a mission to Mars. It's going to happen in 2026 with Ariane 6. We will send a space probe to Mars. We will catch the Mars samples that was collected by Perseverance, and we will bring back to Earth in 2031. So this is very exciting perspectives.
Thank you so much, you two. We're now going to go back to Baptiste, who's with the representative from the European Space Agency. It's back to you, Baptiste.
Okay.
Yeah, thank you, Emma. Thank you, Emma. Sorry. Good evening, Daniel Neuschwander. Welcome to Road to Space. You've worked all your career in space industry, and you are today the Space Agency's Director of Space Transportation. In the last report we saw, the Next Tech report, we saw that Ariane 6 is now turning into reality. Can you tell us what was ESA's role in the development of the launcher?
Yes, good evening to all of you. And ESA's role in the development of Ariane 6 had basically 2 main functions. Number 1, we were the development procuring entity, and second, we were the launch system architect, as you just said it in the film. This means that we define the high-level requirements, we adapt the institutional needs for the future of this launcher, and we accept the deliverables. The deliverables, which is the rocket on the one side, provided on the prime ship of Ariane Group, and on the other side of the launch base, provided by
Acquisition de la
TIS.
télémesure
We
par la
bring it
station de
together at
Malindi
the
au
occasion
Kenya.
of the combined
Il
test,
reste moins de 2 minutes de
where we
propulsion de l'étage
manage
EutelSat.
them through the definition of this combined test, where it has to have a perfect synchronization of these two elements, and we verify that this happens before we go to liftoff.
Well, thank you very much, Daniel. Next to you, we have Marie-Anne-Claire, the director of the Guiana Space Center. Marie-Anne-Claire, do you hear me? Yeah, nice to see you.
Yes, good evening.
We saw also in the report those new buildings have been built for the upcoming launcher. How many people were involved in such a huge work and huge construction?
Trajectoire nominale.
We started the construction for the new launcher Ariane 6 in
everything is looking nominal, and we can see the altitude actually increasing right now, and as March 2020 it pointed out that it was decreasing for some time and then it started increasing. Well, it does, it happens, it kind of happens because you need to, as you can see, that this upper stage basically burns for a long time, okay, and you want to achieve a higher orbit. And if you have played KSP, so when you plot one planetary trajectories, supposed to Duna there, so what happens when you start your burn with your nuclear engine? So your perigee decreases because you actually first of all burn in the direction of Earth, and then slowly increase your nose, the pitch, to the prograde direction, and then finally you head to the the interplanetary space. So because of that, nose not in the prograde direction but slightly below it into the direction of the Earth, the perigee, or the the lowest point of the orbit, decreases, and that's why you first saw the increase, but then it started to nose down a bit, and then because of that, and it has to do it because it has to achieve a higher orbit, geostationary orbit, and it is burning for a long time. So that is the thing, and that's why it's does this thing where it goes to a higher orbit and then do a pitch down, and then finally to its intended orbit. So that's how things work.
What's coming next?
Okay, I guess we
Tonight
have...
in Road to Space, we've just witnessed the launch of Ariane 5 and 2 telecommunication satellites. Shortly, we'll be answering all your questions from social networks and taking a look at the science fiction film Stow Away. We will ask our experts, is it really possible for an intruder to get aboard a rocket?
Nope.
Please, I gotta get back. We're not going back.
This stowaway movie is,
Stay with us for the next part of Road to Space.
This stowaway movie actually has its part from, say intelligence of Mr. Scott Manley. So I haven't watched it, but I will watch it for sure. So we should be getting some pretty good scientific accuracy in that, but not all, obviously, because movies are there for drama and not for actually, what do you say, information. Because if you want the actual information in everything, you can watch a document. So yes.
A point where it creates like a chain reaction, leading to so many debris in orbit that we would actually not be able to use space anymore.
Exactly.
But thankfully, in Europe we have a French space law, which is ruling the way that we are performing our launch missions in a way that we are observing the best practice in order to really make launch services in a most sustainable approach.
Yes, indeed. So I just told you about the fact that you can reignite the upper stage of Ariane 6. We'll be able to do that, which means that at the end of the mission, once you've deployed the satellites, you'll be able to reignite the Vinci engine or the APU to perform a deorbitation, which means that you remove the upper stage from its orbit. So it means basically that at the end of the mission, we clean behind us.
Yeah, the Kessler syndrome, the Kessler effect you're talking about reminds me of the first sequence we had in the movie Gravity. Is it the same thing?
This is exactly the type of catastrophic event. that you're
Maybe more studying movies than...
We are not there yet, thanks to Thomas Pesquet.
Well, thank you very much. Thank you both for all this information. Thank you very much. We have more questions for you, and we will try to answer all of them by the end of the program. But now it's time for us to focus on Embratel satellite Star 1 D2, which is just about to separate from Ariane 5. So we're waiting for this moment. And Amandine, you will tell us?
Yeah, I will tell you. For the moment, we are doing all the maneuvers necessary before the separation of the satellite. It's what we call the space ballet. So you want to get to the right altitude, the one desired by the customers, the right spin. And I did have the confirmation of Star 1 D2.
And we have the confirmation.
So far, so good. Let's go back right now to Kourou, where normally Cyrielle should be linked with us. Cyrielle, are you waiting? Do you hear us, Cyrielle? Well, we can see all the faces in the Jupiter room. Everybody is really concentrated. Cyrielle, it's good to see you. What's the atmosphere?
Yes, welcome back, Baptiste. Well, actually, as you can see, still tensed. We just got the confirmation of the separation for Star 1 D2, but let's remember that we still have a second passenger on board, and the mission is not over just yet. So that's why you see that people are still working, concentrated, and we're waiting for the next update.
Well, thank you very much. We could say that half of the job is done, main part of it, but we still have a big issue. And this issue, Amandine, we are going to talk about this first separation with you, Raphael. But just before, Amandine, can you tell us more about SILDA?
Okay, the SILDA is the black cone that you can see on the animation. So that's what we call the dual launch structure, and that allows us to perform the dual launch configuration. And in fact, what you want to do is to make the most of all the performance available. I did have the confirmation of the separation of the SILDA. So the SILDA is the structure that allows you to embark two satellites that want to go to the same direction. Okay. And in fact, if we want to talk about innovation, that's somehow a precursor of the next White-Share mission. And now we will perform the next maneuvers in order to get to the right attitude and orientation for EutelSat Quantum.
Thank you, Amandine. Now, if I can come back to you, Raphael, and talk about the first separation that just happened. For the operator, Embratel, this must be such a relief for all the teams over there. They were under such a lot of pressure. What do you think?
Yeah, of course. I mean, like Cyrielle and Amandine said, Ariane is actually designed to do dual launch, so we are separating two satellites in orbit. Baptiste said that half of the job was done. Actually, we have three separations. The first satellite, the SILDA, and the lower satellite. It means that I can let you imagine if the SILDA is not rightly separated, what's going to happen when we try to separate the last satellite. So, of course, everybody is still focused on the rest of the mission.
Yeah, actually, yeah, we were focusing on the satellites, but yeah, there's the SILDA is, I mean, if it's still there, I guess you can't separate from the second satellite.
You have some problems, yes, okay. I can feel.
Well, before we focus on the separation of the EutelSat Quantum, the second satellite, we are going to take you on a journey, on a voyage. We are going to watch the trailer of the science fiction film named Stowaway, and then we are going to try to answer a question called a passager clandestin, an intruder, an illegal intruder gets into a rocket. Let's watch the trailer of the movie.
Okay. Actually, I guess they shot the movie in Arianespace. Okay. I don't think so. I'll get a copyright for sure.
I'm a launch support engineer, ma'am. How long was I out?
We took off about 12 hours ago.
12 hours. I need to get back to my sister, please. My sister, she's alone. Please, I gotta get back.
We're not going back.
What do you mean we're not going back? This is a 2-year mission.
2 years is a long time to be away, but this is the opportunity of a lifetime.
That was. Well, welcome you both back to the fact-checking segment from Road to Space Living Room. I have with me, I'm just going through the trailer, and for all of those of you who haven't seen it or haven't seen the film, maybe I should put you back in the picture of the summary. It's the story of a 3-person crew on a 2-year mission to Mars and the dilemma they face when an unplanned 4th passenger suddenly arrives on board, what we call the stowaway. So my first question, obviously, to you both is this a plausible scenario?
I really hope not. No, if it happens, I really would advise the launch service provider to rethink its processes, because it's all about processes, right?
Yeah, if you think about when we manufacture the launcher, everything is checked, because one of the risks that we fear is what we call foreign object damage. Okay, so that we have you forgot a screwdriver, a tool, anything, and it damages the rocket during the launch. So everything's monitored.
Yeah, and every tool is labeled, and you have a specific team who is taking care of making sure that nothing is left inside the launch vehicle.
So everything inside, okay, but what about outside? I mean, we are in Kourou, for God's sake. It's a tropical jungle out there. What about mosquitoes flying around? What about animals?
Okay, yeah, I can confirm. Kourou is wild. Yeah, when you're there, when you're dealing with a huge integration holes, what you fear is that some birds, for instance, get inside the buildings.
This is why we had to hire also an animal specialist in animals' behavior, who's in charge of, when we open the door, to place traps, to actually make diversions with flashlights, etc., in order to prevent animals to come in.
What about dust particles getting into the top of the satellite?
Yeah, even a speck of dust is an issue for us. So that's why the air is filtered around the satellites and clearly monitored.
Yeah, and for scientific payloads, it's even worse, like the James Webb Space Telescope that we will be we will launch at the end of this year.
I think we have some images here of the cleanliness curtain.
You know, a speck of dust would really damage the mission and make this telescope blind. You see that here they are using UV lamp in order to really detect the dirt there. If, for example, if you're proud of the cleanliness of your bathroom, just light it up with a UV lamp, and I promise that you will never want to shower again there.
Why would you do that?
Thank you so much, guys. Well, now I know, I'm reassured that there is no way an intruder can get into an Ariane 5 rocket. Well, I think we're going to go over now to Kourou and go over to Baptiste, who will be talking about the separation of the EutelSat Quantum. Let's go over to him now.
Yes, Emma, in less than 10 seconds, more or less 10 seconds, EutelSat Quantum satellite should be released from Ariane 5 launcher. So that's really a crucial point. We're waiting, and we should see the people happy and clapping if everything is turning good, and that should be on the predicted time, 10 seconds away.
So we had the acquisition of the white attitude.
Okay.
So here it's quiet, but lots of things happening over there.
We'll get the separation.
Yes, we had the separation of EutelSat Mission. So that's the end of the mission for the launch vehicle.
Okay, so we hear people clapping. I see your face. I see your face, Raphael, and Mathieu also. So I guess this is, in a way, the end of the mission. Let's go back immediately to Kourou to see the atmosphere over there. Yeah, you can see the team cheering up, clapping. And now we should be linked with Stéphane Israël. Stéphane Israël, are you there? I remember Stéphane Israël is the CEO.
Sure. I am here with you.
Okay, yeah. You still have your mask, but I can figure out a huge smile. Yeah.
Whoa,
yeah.
Nice.
So you're happy. Good news. And good customers.
I'm very happy,
customers.
but I am happy for my customers. Yes, for sure. It's very important for our customers.
Well, it's okay. This is why we are launching satellite, because we have a little delay between Stéphane and me. And well, you were talking about your happy customers. I guess it's really important for you.
Yes, it's very important for Arianespace because it was the first Ariane 5 of the year, and it had to be a success. And tonight it's a great success. It's very important for us to pay the tribute to all the contributors of this success. We have our prime Ariane group. We have here with us CNES, which is our daily partner in CSG. We have ESA. It is a success of the whole European team, for sure, Arianespace as well. And for our customers, Brazilian customer Embratel, French customer EutelSat, very innovative satellite, Maxar, American manufacturer, Airbus Defence and Space, European manufacturer. Tonight, it's a victory for all of them, and I really want to thank them for their trust to Arianespace.
And it's a great start for what you call the Ariane season, because it's just the first launching.
Yes, it is the first of the Ariane season, and you know that now we have two very important Ariane 5 which are about to be launched. One will be for SES and the French DGA, and the other one for James Webb Telescope. It will be the climax of the year. And we have also, during this summer, a very busy summer, we will have Vega for Pléiades Neo for Airbus on August 16th, and then a Soyuz from Baikonur on August 19th for OneWeb. So it is also the beginning of a busy summer for all our teams.
Well, thank you very much. Good luck for a huge job you have during the summer, and we'll be watching, definitely, we'll be watching the next launching. Thank you very much, Stéphane.
Meanwhile, let's take a moment to answer one last time the question sent by our audience, and it sure is a headline topic we've kept for you. Let's take a look with our first tweet from Astro Hayden, who I believe is a guy. Greetings, Arianespace. I'm very excited for the future with advancement of technology capabilities. How far are we away to one day launching humans on an Ariane rocket?
Yeah. That's a question for Ariane.
Okay. But I can confirm it's a boy, actually. We know well.
It's a boy?
Yeah, during lockdown, he made very good use of his time, because with his parents, he built an Ariane 6 model, which is very, very nice.
So he's probably one. He will be maybe sitting on your chair.
Yeah, and maybe he'll build rockets that bring human to space.
Yeah.
And I'll tell you why, because I think we have all the techno bricks to go to space. What do you need? You need to have a reliable launcher with high performance. That's what you'll get with Ariane 6, because we'll be able to launch more than 4 astronauts to space with the performance we'll get. You need to be able to re-enter from space. This is something that has been demonstrated with the IXV program. It will be done with the Space Rider, something that we master. And then the final brick would be, can you do a capsule? Can you do a spaceship that goes to space? We did that 5 times, launched by Ariane 5 with the automated transfer vehicle. But we are still doing things on that topic with Orion, for instance.
Yeah, we can mention that ESA is implied in the Orion module, which will bring human back to the moon, actually.
Whoa.
Yeah, so I actually really agree with you, Mathieu, that Europe has everything needed to do this. The experience, the technology, and the motivation also.
Oh, yeah.
And as a matter of fact, also in a more commercial perspective, this market is getting stronger and stronger. Today, with astronauts going more often into the ISS, that is where our European hero, Thomas Pesquet, is actually
he's
running
watching our live now.
I hope he is watching us. Yes. Hello, Thomas. And tomorrow, many more astronauts going to the moon. And so, yes, just...
Let me ask you a stupid question. Why should human go back on the moon?
For many, many reasons. First of all, because I was not born when it happened before. Okay? So I need to do this live. And the moon is also very scientific, a lot of scientific interest. Because we went there, but we didn't. We went to a very few locations on the moon, and we brought back samples that are very limited, and the moon can really bring us knowledge on how the Earth was formed. But also the moon has resources on the surface. You can, for example, transform the regoliths, which is the dust that is covering the surface of the moon, into water or oxygen. So it really gives you the conditions to really dream of a sustainable presence of a human on the moon. And you can also dream of transforming it into fuel in order to fuel rockets that would lift off from the moon and go deeper in space, for example, Mars, but even deeper than that. So lots of very exciting perspectives on the moon.
That's a dreamer.
That's a dream.
We had another question on social media.
We had one from Roman, Batman he's called. Is the Ariane 5 officially certified to fly humans?
I think it refers to the fact that Ariane 5 was also initially thought to be flying Hermes, which was the European spaceship somehow program, but it didn't happen. But there's a good point about this is that the high reliability you have with Ariane 5 is actually in the DNA of the rocket because of this ambition. So it has not been certified per se for human spaceflight, but still we somehow inherit from it.
Okay, can we dream big and imagine, for example, a space station like the ISS around the moon?
This is not a dream. It's actually happening.
Yeah.
Like the ISS, the International Space Station, is going to come to an end, and the states that are investing in the ISS are thinking and building right now a lunar gateway, which is like an international space station around the moon, in order to make this sustainable presence of human astronauts around the moon a reality. And Europe is actively participating to this, to some module of these space stations. So yes, you need to dream much bigger.
But you think bigger. Well, we'll have a lot of topics to discuss on the next shows because it's really interesting. Sure. That's a key. That's a question that is interesting everybody. Yeah. Thank you very much, both of you, for all this information. And we are now going back to Kourou to see how the teams are going and to meet some really happy customers, I guess. Hello, Cyril. It looks you've changed place.
Yes, actually, I'm a little closer to the main screen we have in the fishbowl.
Well, okay, so close to the main stage. Well, Cyril, it looks like it is time for us to meet our next special guest. We have Pascal Omzi, CTO of EutelSat, Elodie Viau, Director of Telecommunications and Integrated Applications at ESA, and we have also Christophe Dallest, EutelSat Quantum Program Manager at Airbus Defence and Space. It's hard to say. Can you ask them some questions for us, please?
Yes, of course, Baptiste. So, Pascal, you just saw your satellite separate from Ariane 5. How do you feel?
Well, I have to say that I feel absolutely incredible. So we have received the telemetry. I can even say that I have breathed the quantum sigh of relief, to be honest. It has been a long journey with this satellite, which has met some challenges. But we're extremely happy to have witnessed this beautiful launch today.
Well, thank you. EutelSat Quantum is what we can call a game changer. What is it going to change and how important is it for your company?
So EutelSat Quantum is indeed a game changer. It's a satellite of a new type, a flexible satellite, which will be able to be controlled in orbit from the ground through software. So that is a great advantage for our client. So coverage and power, spectrum and capacity are going to be reconfigurable at any time. So this makes an extremely good use of resources. So it opens also the door for new applications like data, government and maritime applications.
Well, thank you, Pascal. So, Elodie, the satellite was developed under a public-private partnership, right?
Exactly. So Quantum Satellite is a satellite that has been developed on a private partnership, public partnership, with the operator EutelSat and this European Space Agency. So these public-private partnerships allow us to share the risk with the operator and boost the innovation that EutelSat Quantum Satellite is carrying on board.
Okay, so it is really important for the European landscape, right?
Yes, so many countries, 6 countries got together to support all the innovation developed on board of EutelSat Quantum. So UK, the Netherlands, Spain and Italy, as well as Norway and Canada, boost their industry and supporting the commercial private actors. In addition to that, we have now EutelSat Quantum that is leading the way of getting towards software-defined satellites. And there is now the next generation of satellites that they are under development with a lot of innovation between the European Space Agency and all the commercial actors.
Wow, that sounds incredible. Thank you, Elodie. So now, Christophe, it has been a long journey for your team. They had to develop brand new technologies for the satellite. How is it to be part of such an incredible journey?
Well, it was a very exciting project. I would like first to thank the Airbus teams in the UK, in France, in Spain, in Italy, in the Netherlands, and as well as the SSTL team for their hard work and dedication throughout the program. The program has been made possible by the very strong support from ESA through this public-private partnership, and as well thanks to the very constant will of EutelSat to go throughout the program. So it has been a very important experience. Now we have received the spacecraft telemetry. We know that we have a bit of critical operation to perform in order to complete the job and to go through the early orbit phase and through the in-orbit acceptance. But I'm sure that the Airbus team, along with all the partners, will carry on to bring the customer satisfaction at a high level.
Well, thank you, Christophe. Now, Pascal, one last word for your team and partners.
Well, I would like to thank, obviously, our supplier and partner, Airbus, the teams in the UK and in France who have been working on this satellite for quite some time. I would like also to thank the European Space Agency and the UK Space Agency for having contributed to the funding of the development and construction of the satellite. Of course, our long historical partner, Arianespace, who offered us a fantastic launch today. I would like also to thank our co-passenger, Star 1D2, with the team of Marcello, who shared the ride with us today. And of course, the team of EutelSat, those who are here with me and those who are also back in Europe, who have been working on this satellite. Now the time has come to go and sell. I have a personal note for Philippe Oliva, my colleague from EutelSat, who is the Chief Commercial Officer. Philippe, now you have the satellite, you can go and sell, and I wish EutelSat Quantum a really long life and a commercial success. Thank you very much.
Well, thank you, Pascal. We shared you too.
And thank you to you all over there. Thank you, Cyril. Cyril, it looks like it's time now to meet with another special guest. You have a representative with you from Embratel, is that right?
Okay, let me just say now, I think, okay, if I can say, right?
What is it like for Embratel to have another satellite successfully launched?
Okay, cool. So, guys, whatever be the stream be like for today's launch, let's appreciate the fact that Arianespace did cover the bonus stuff pretty well. Okay, I can see some, comments coming in and all those things about how bad this broadcast is, but we need to understand one thing, that we have been seeing the SpaceX launches for so long now that we have considered it as like baseline for the launch streams, like that's how a launch stream should be. But if you see this launch stream which you just saw, Arianespace, it was more directed to the general public. It was not for us space fans. But with that being said, I won't say that it was pretty good or it was the best of the best they can do. No, not at all, because they can satisfy both the customers, both the audience, I guess, the space fans, the space nerds like us, and the general public. Because the launch coverage which happened, we didn't get to see the rocket for so long, and there can be so many improvements that we can suggest right now. And everyone, this I don't know what happens, but this is a thing which they need to figure out first of all. Okay, yeah, I was saying that let's not hate on this because they've covered those bonus stuff. I know they are the rocket launcher company and they provide the the coverage for the rocket launch, which they didn't do for today's launch. I will admit that, but the bonus stuff, the other things, those animation about the satellite and all was pretty good, I must say that. But again, you are a rocket company and you are providing a launch coverage, so we do expect some launch coverage to happen. Maybe have some sections, like if you want to address the general public, you can have a talk session like they are having right now, or before the rocket launch. Talk session before the rocket launch, basically, or like 40 minutes before you start the stream, 40 minutes before the launch. You want to talk about anything you want, okay, you just talk. But during like t minus 20, t minus 30 minutes, let's have a stream for the SpaceX kind of people, like what SpaceX do. So that's how you can kind of cover both of the audiences and make everyone happy. But see this, not from my end, but this is the thing which they are having. For some reason they just cut off the stream, just cut off from the back end. It's not like the stream has ended or something like that, because the black screen is there in constant playing. The black screen is actually playing, not like buffering. So yes, that is the thing here. So I guess they do need to improve on their rocket launch coverage. Otherwise, the bonus thing which they covered today, I appreciate it. I actually appreciated it. Whatever that guy, actually, I love that guy. The questions which he asked and everything. And see the actual this you can see this here. They were able to get this rocket launch video after that also, means after it has passed through those clouds. So maybe they could have just switch over to this. There are certain kind of things which they need to improve, which we can suggest, but again, that is a thing which we are all complaining about for so long. They did improve some coverage today. This was not what they did previously. They did improve something, but they improved the bonus part. They are a rocket launched cast company, yeah, provider. So that was not the focus, basically. That's what I'm trying to say. Other than the rocket launch, everything was perfect, I guess. So yeah. Okay, so this is literally, you can see that they are giving the credits also right now. So they literally produced a movie kind of a thing, a documentary per se. So that is a thing. Okay, let's move on to the Twitter and talk about the things which we do after these launches, right? Okay, let's do that. Fine. Incredibly proud of my team. The first road to space has been a tremendous moment and a success. Okay. Many people around the world discovered the excitement of mission, tracing the routes to space, the best broadcast live we have ever done. Whoa, okay. Who's he? Agree. Okay, bro, I don't know. But okay. Fixing a problem starts with acknowledging that a problem exists. Chief Brand and Communication Officer of Arianespace. Seriously, though, I do not mean to be rude, but okay. We seriously, I'm repeating myself, we seriously need to understand the targeted audience they were actually targeting. They were not targeting the space nerds like us. So they did provide the coverage according to the general public, I guess. But again, there are so many things which can be improved, and yes, we want that to happen. But otherwise, there will be a lot of trolling which will happen. But looking at it from a mature perspective, I must say that the stream was pretty good. It was a knowledgeable stream, I must admit that, but it was not a rocket launch stream. It was like a discussion stream. That was missing. Okay. Other than that, the raw fees for these the liquid hydrogen oxygen rockets are incredible to watch. When they power up, and you if you look at it properly, you will see the fireball also happening. But again, this is not as big as the fireball which the Ariane 5 rocket, sorry, the Delta 4 Heavy rocket creates, because of how it works. Okay. Otherwise, everything was good. Whole way. Yeah. Okay. Was watching my stream. Tiger, you shout out to you. Cool. Okay. Congrats on the launch. I don't know how much time again. Fix the webcast. Okay, cool. Okay, let's talk about the Nayoka now. Maybe because everything else is done. The mission was successful. We did get some. Oh yeah, this one S20 nose con. This is being prepared right now, and this white structure which you see on this thing is like it's the heat shield is being installed basically, and this is like the sheet on which those tiles will be pasted. I guess this is the what do you I say, the pathfinder to the proper heat shield which the Starship will be having, because I remember the Elon Musk actually told that the tiles, the heat shield on the Starship will be bolted. I don't know what does he mean by bolted. I don't think so it will be like literally bolted to the surface, but maybe attached to it with a proper no. Let's see how things roll out, but right now that is the case. Okay. And yes, this is one thing which happened here, that the NASA actually ruled out the plans, the protest from the Blue Origin and the Dynetics lander, that you are having just a single human landing system for Artemis. So that is one thing which happened today only. NASA was notified that the US Government Accountability Office has denied the protest filed by the Blue Origin and Dynetics and upheld the agency's source selection of SpaceX to continue the development of human landing system. The decision enables NASA to award the contract that will ultimately result in the first crewed demonstration landing on the moon. Importantly, our decision will allow NASA and SpaceX to establish a timeline for the first crew landing on the moon in more than 50. NASA recognizes that sending American astronauts back to the moon for the first time since the Apollo program and establishing a long-term presence on the moon is priority for the Biden administration and is imperative for maintaining American leadership in space in the face of challenges during the last year. NASA and its partner have made significant achievements. Okay. Doing successful hot fire test. Uncrewed flight of Artemis 1 is on the track for this year, and a crewed is Artemis 2 is planned for 23. Okay. I guess that's a good decision. I guess. Okay. Let me make my comment here. This is a good decision for short term. I mean, if you want to fast track the process, obviously go with SpaceX for the initial part. But then afterwards, when you kind of have established all the technologies for going back to the moon again, maybe about the contracts to Blue Origin and Dynetics also, because that will add redundancy. Having all the what is that saying, having all the chickens in one bucket, that's the thing. I don't remember all the eggs in the one bucket. I don't remember the saying, but you get my point. Having all those things in one place will create some problem. Maybe SpaceX is a very, very reliable company. It's not that I'm saying that they can't handle being the only provider. But again, it's always better to have one redundancy in space missions. Okay, cool. So the rocket So the rocket that was not being shown, and that was not being shown, but at the end we just saw the rocket for literally just for 10 seconds or so, and then again the animation, all those. Exactly. They have such so good animations and everything. The production quality which they do on in Arianespace, production quality is actually the best for all the launch webcasts. But again, the main thing, the main content for your broadcast is the rocket launch and the rocket associated with it. So it's better to show that. Okay, what was I saying? The Nayoka. Do we have any other thing for Nayoka? Nope. Better to just have a look. Yes. Let's talk about Nayoka now. You do have any questions, you can ask me here, and I'll try to answer them. There was some, questions I missed also. Is I have planned to do the reusable rocket with, yes, it does. They do have, I mean, the ESA is like on, R&D stage for the reusability right now. They are more focused on Ariane 6 first of all. Once that is developed and launched and is in operation, then they will focus on reusability. So yeah, and people are like, when you are people nowadays, what people think is that when you are developing a new rocket, so why aren't you thinking about reusability for that? The simple answer is the reusability is the next step. First of all, you need to make one rocket, you need to make those technologies for that rocket to work, and then after you have established that, next step is the reusability. SpaceX also, with the Falcon 1, they did the expandable configuration, and then they went with the Falcon 9 for the reusability. Again, if you talk about the Ariane 6, yes, you can say that they could have gone with reusability with the Ariane 6, but Ariane 6 was, is in development since so long now that it's the need of the hour for Arianespace, basically. It's the low cost rocket than Ariane 5, and literally a reignitable upper stage is a thing which is so important nowadays, and that was lacking on Ariane 5, which is like a biggest hurdle, and Ariane 6 will solve that. So yes, that's a big win, I guess. It's like an upgrade, bigger upgrade for to Ariane 6 from Ariane 5, but again, it's not like can get away with the reusability. Talking about the reusability, the programs all over the world, first of all, they need to develop those technologies. First of all, like take the example for the ISRO is right now does not have a heavy launcher, right? It does not have the cryogenic fuel or the engines for the first stage or the booster stage. So it's better to first of all develop those technologies, make an expendable rocket. It's okay, totally fine. I'm totally fine with it. And you develop those technology, you have the HLV, which they are developing the heavy launch vehicle. And I like this thing the best. Like now they are developing the HLV, which is their newest rocket, but they are thinking reusability in the mind. So first of all, in if the initial versions of HLV, which is nothing but the heavier launch vehicle for ISRO, will be fully expendable, but afterwards, once they have established the technologies for HLV, they will convert it into a reusable rocket with their Admire program. So I think that is the way to go forward. If you want to, if you are developing a new, rocket also, okay, develop it, use it in expendable configuration for some time, and then upgrade it for reusable configuration also. So that is the thing I think we should be progressing. So yeah, I guess. Now, if you have any other thing to ask, you can ask me. And those of you all who don't know about the drama which we had for the Nayoka module, okay, let's talk about that. Been talking about things a lot, but not about the main, the showstopper for today's flight. It should have been the launch, but okay, let's so Nayoka, it was launched on the Proton rocket. The launch went pretty well. Everything was good. The Proton rocket, I like the rocket. I don't know about you. We have the people who can debate on if the rocket is ugly or not. But Proton is retiring, and it will be replaced by Angara. So okay. So yeah, the Proton rocket did put it into the correct trajectory, the correct orbit. But after putting it into the orbit, Nayoka had issues, which was expected because it was delayed for like 20 years. And the issues actually, okay, talking about the issues for the spacecrafts. First of all, if you have the most important thing to have on the spacecraft, if you ask me what is the most important thing on the spacecraft you want to have, I would say two things, which is power and communication. Okay, this is the most important thing, and this has to be the perfect. This has to be perfect without any problem. I would invest the major amount of my money on power and communication just to make it the most reliable. Because here with the Nayoka you can relate also, because whenever we have power as well as communication, no matter whatever whatever we have the problems with the other systems, we can resolve it, because we can send the comments, we can send what is actually happening. And then as spacecrafts are developed in a way that redundancy is there, so you can figure out something in orbit also, in space also, basically. But you need to have power and communication there. If you don't have those, you can't do anything about it. So that is the most important thing for any spacecraft to have, the power and the communication. This is the thing which I'm talking about for a normal spacecraft which is not human rated. When it comes to human space flight, that is a totally different story. But yeah, talking about Nayoka, coming back to Nayoka, so what happened was it placed it into correct orbit. Everything was fine, but when the system checks were performed, everything was powered up. First of all, the Kursk antenna, which is actually the docking system for the Nayoka module, that was not deploying. First problem. Then the attitude control thrusters, which are the RCS, they were having some problem with that also, with one not firing. And then the main problem was the propulsion. So the propulsion, for the Nayoka module, the propulsion system for the Nayoka module is like they have the main engine, which is for the most of the maneuvers. Then we have the attitude control thrusters, the RCS thruster basically, and then we have another set of thrusters which are used when they are closed in for docking, and they are near the International Space Station. So they have these three set of thrusters. So the main engines for the Nayoka went down when they were launched. Okay, so in the orbit they were not able to fire properly. And Scott Manley did a great video explaining what happened with the the main engine not firing. So you can check that out. But I will say that it was just not firing, and they had to use the RCS thrusters then to correct the orbit, to raise the orbit and all those things. And then what happened was they did that, everything was good, because since they used the RCS thrusters, the RCS fuel a lot, they didn't have enough fuel to perform docking in the second docking, in case the first was an abort. Okay, so that was another thing. So they literally had one attempt on docking. Whatever they after they figure out everything, they literally had one attempt on docking. So they finally, everything, after they perform every system check and everything, they raised the orbit, they rendezvoused with the ISS, and then they finally docked with the ISS. Okay, everyone was congratulated, everyone had a sigh of relief, and everyone was like, okay, this thing was the bad pretty badass thing which we accomplished, and this was the hardest docking which they did, I guess that's what they said. But yeah, you get my point. But after some time, to everyone's surprise, one thruster on the Nayoka started firing, and because of that, it introduced a roll in on ISS. Okay, the role on ISS is like, what do I say, is not desirable as such, because role can induce the centripetal force on the component, so it can rip apart if it is rolling too fast. But again, that's a pretty big structure, and it requires a you know certain amount of rotations per second, which is like pretty large. So I don't think so that is the main problem. The main problem was with the resonance of the thruster. Whenever a thruster fire, there is one vibration is created, and if that vibration resonates with the ISS, because that at that point of time the Nayoka was not configured with the ISS. Whenever a spacecraft docks with an ISS, what do? They configure their system with the ISS system. So now they don't consider that the spacecraft computer basically don't consider itself as a separate body, but with the ISS. So that's how the integration works. So when it was docked, the Nayoka was docked. It was in the process of integrating the systems with the ISS, but again it thought that it is still not it was not integrated. It was in the process, and then the thruster started firing. It induced some roll, and the ISS roll control system was alerted that now you are getting the loss of attitude control, or lack as they say, and they it was alerted. So initially ISS gyros, or the reaction control wheels for the layman terms, they worked, and they tried to counteract the thrust with the roll which was provided by the uh, Nayoka. Again, that was not enough. Okay, so again the ISS thrusters itself started firing to counteract that, but that was also not enough. Finally, the Russian segment, the progress thrusters were commanded to fire to counteract with what Nayoka was doing, and then finally it was everything was under control. I think people say that it ran out of fuel, but we don't have any confirmation. But yes, that's what happened. So because of this role and everything, the attitude of the ISS literally got changed by 45 degrees, and even more. Uh, we don't have the confirmation. They were saying that 45 degrees, but um, as Scott Manley pointed out, that the video which the ISS cameras uh, produce when they look back to the Earth, we can from there we can see actually how much the ISS actually lost the altitude, and that was not 45 degrees, it was more than that. Okay? So even the progress was firing, the ISS thrusters was firing, the gyros were working, but again this small Nayoka was able to do a 45-degree roll for the big ISS. So that was one thing, and then finally everything was back to normal there. um, the astronauts were never in danger, and yes, but the side effect of all those things which I just explained uh, had to do with the Starliner. The Starliner finally got delayed again, and it will now be launched on 4th August. Whew, so that's the whole story. So that's what actually happened today. Not today, basically, yeah, this week. But hats off to Russian scientists and engineers and in the people involved in Roscosmos that they finally figured out everything, whatever the fault was, and they, finally docked with the ISS. Now, since it is docked with the ISS, now whatever repairs are necessary, they will be able to do it. That is not a problem. The Russian cosmonauts can do an EVA if required. And basically now you can do the human, you can have the human intervention to repair anything. So, but that anything comes with the terms and condition that you should be having those tools and capability to repair that. Okay. I guess we don't have the questions right now, but we had this beautiful launch of the Ariane 5. That was the, you know, the thing for today, the biggest thing for today, this Vulcan engine firing. And then this Ariane 5 lifting onto the space and finally going to the geostationary transfer orbit. Cool. Okay. Kilo Vega, yes. This was that's what I was saying. The Vega's production was like way say worse than today's one. So yeah. Okay, this is the the parody account. So it's supposed to do this, I guess. Otherwise, everything looks perfect right now. We don't have think. Okay, I guess then I can end this stream. We don't have any other update for today, and we just saw this beautiful liftoff of this rocket. If you have any questions, you can ask me. Otherwise, we can end this stream. And thank you so much all for tuning in. Okay, talking about the next launch. Next launch, I guess, will be of the Starliner itself. But let me just confirm it once. Oh, we do have one Soyuz 1.7V. What does it? 2.V. Yeah, 2.V. Soyuz 2.V version of a launch is coming up on today and tomorrow. But I don't think so. We will have any live stream for that because it's the launch of the Ministry of Defense of the Russian Federation. So no live stream. The Momo rocket is launching, but I won't be live streaming it because of my exams. My exams are like literally, getting postponed or coming right back to its track. So this August month, maybe you maybe I will try to do all the launches, but maybe some of the other I may miss. So pardon me for that. So the next major launch is the Starliner one. So I'll stream that. So no worries with it. And then the Antares rocket launch. In between, we will be having, let's hope the ViaSat solves its issue and we'll have the Starlink launch also. And yeah, okay. Thank you so much, Andrew Gaming. Do I pronounce your name correctly? I don't think so, but okay, you get my feelings what I want to say. But okay, guys, I think that's it for today. That will do for today. I guess I talked about things a lot, and I guess you liked the stream. If you did like, do give it a thumbs up and subscribe if you haven't. I covered all the launches, the space events, videos, all in one package in this channel. If you like what I do, you can just hit that like button, subscribe, and if you want to support me, you can do that by becoming a member of this channel by clicking that join button, or a Patreon if you are comfortable with that. The Patreon link is down in the description. It really helps this channel to stay alive, because now I guess I'm a US taxpayer. There are some new laws which have come, and all the revenue which I earn from US has some cut which goes to the US government, but I don't get any privileges for taxpayers as such. So revenue is like, going down by down. So okay, that's why I'm just saying it helps the channel stay alive. If you want, you can become the chair member, and you'll get those exclusive perks and all those things. So yeah. Yes, was the launch successful? Yes, Yehuda, it was. The launch was successful, very much successful, and everything went pretty well. So that is that. So I guess now I can end the stream. Thank you so much, all of you, for joining in. Really appreciate all of your love and support, and we'll see you on another launch, probably the Starliner launch on 3rd or 4th of August, wherever you live, and we'll get back to it. And let's hope Boeing Starliner has nails it to the ISS this time. So until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.